Who am I? Why am I here? Now, this is part 4 of the GTK4/GObject tutorial, and by God, it's going to be a doozy, folks. It really is. In this episode, we are going to start some custom drawing, yes. And so there's going to be a lot of ground to cover, so I'm not going to be able to walk you through each and every line of code the way that I have in the previous videos, but I will try my best to walk you through most things. And what I've done is I've created Git Branches for part 4 and broken it up into 3 parts. I've got part 4A, B, and C. So you can always jump between those 3 segments of it, and you can compare and contrast using Git. If you clone the Git repo, and you can see where things change from part to part, if you really want to see how things come together without having to follow every single line of code as I go in the video. Okay, so let's go to the master and let us make clean, and then we'll run our demo widget file. So here we go. We've got a standard GTK button now to the right, and then here's the custom widget here that we are going to be creating. And as you can see, when you click on the foobar bars, it highlights, and when you click it again, it unhighlights, and you've got our demo widget says hello here. And if you click this button as well, it also does the same thing. And so basically, we've used some signals, we've used some properties, we have drawn the widget by hand. This is not a GTK label, it's not a GTK button. Everything we've done manually. Everything's been done by hand. Okay, so it doesn't look like much, but there's a lot we need to go through. There's a lot of code here. So let's close this and let's go check out part 4A. So let's open up the main.c file first, just to really quickly show you how we've still got our dummy foobar callback here. We will not be using that. But now in our activate function, we've created a window, and now we have a box that's going to be the parent container for both our demo widget and a standard button, like I just showed you. So everything's the same there, but now we have created a button as well as the demo widget, and we're appending the button and the demo widget to the box. And then instead of making the demo widget a direct child of the window, we are making the box the child of the window. So that's the way we're doing it. This GObject set is the same thing to set our label of our button, and we're still connected to the foobar signal, but it's just that signal now will do nothing in this part. We'll resolve that once we add to the widget a little bit more. Okay, so let's open up our demo widget.c file. To the top, properties are the same. Like I said, the foobar signal has not changed because we haven't implemented that yet. So that's a dummy signal. So in this version, we've added just a car star to the object, which is a label. Sorry, it's a car star, and we're calling it label. So we would access that by using self arrow label. Okay, so let's actually skip now to the bottom of the file. And so this is all the same. This is the same. Now, setting the label, we've had to make a few changes. Okay, so we're still notifying that the property has changed, but now we are actually setting the label car star in our object to be the const car star label that is passed in. So, and then we're going to go ahead and queue a draw. Okay, and we're notifying by pspec that the property has changed. All right, so queuing the draw will actually enable us to have the widget change its label, and we'll show how that will happen soon. Scroll up here. This is all the same. However, we're in our class init function now. I did create a shorthand for widget class. Like I said in the past, you could do, but there was no point before. But now that we're doing more in terms of setting virtual functions, I thought it would be a good idea to set that shorthand. So we've now got the widget class shorthand, and we're going to override the snapshot virtual function, and we're going to implement that in a function called demo widget snapshot. This is new to GTK4. In GTK3, what you would do is you connect to the draw signal, and you would use a GTK drawing area, you can still do that, but I just didn't think that there was much point in doing things sort of the old way, that they're probably, if I wouldn't be surprised, trying to phase out for GTK4, but they kind of have still kept for backwards compatibility. You're stuck pretty much using Cairo if you do things that way, so I wanted to do things in more of a GTK4-ish way, okay? So why don't we just go ahead and go straight to that function here. So the prototype for any snapshot subroutine is it takes a GTK widget star and it takes a GTK snapshot star. Now, we do the same thing that we do in any private method, or any method really in one of our objects, which is we create our self parameter. Now here are some declarations here. So we need to create a GTK Css Provider, which is rather an object that can feed CSS to things in GTK. We have our style context, which will enable us to it's an object that really carries the metadata of the style of your object, and it can be manipulated in different ways. And then when you're drawing pieces of your parts of your widget, that context will then be tapped into to find out how to draw things in certain ways. Now the Pango Layout is a raw text rendering object utilized with GTK. Whenever you see text being drawn in GTK, Pango behind the scenes is what's doing that drawing. And so that's why that's what we're going to use to get some text on the screen. It's a very low level, well, relatively low level within the GTK ecosystem. And we need to define declare GTK Allocation. Notice that this is not a pointer because it's just a struct that just has integers of x, y, width, and height in it, and we're going to need this for some of our functions that are run here. And just be aware that GTK and GDK and all those families of items have tons of rectangles, okay? There's GTK rectangle, there's GTK allocation, which is just a type def to a GTK rectangle, there's a Cairo rectangle, there's a graphene rectangle, there's a Pango rectangle, I think. There's just tons of rectangles, and not all of them are compatible, so just be aware of that and follow the documentation closely. So first we're going to generate a Pango layout by running GTK widget create Pango layout. Very easy, just pass null to it to give it no text by default. And then we're going to set the text and in order to do that, we're going to use our getLabel function, which, if I make a mark here, and if I just go to, all it does is return self arrow label. So really, we don't really need to call that here, but if we change the implementation down the road, it could be a good practice to do it. You'll see in future amendments that we make, we won't always be running that function every time, but there's more than one way to do it. So let's do it let's keep it that way for now. Context is equal to GTK widget get style context on the widget, so that gives us our widgets context that is already sort of utilized already by default within GTK. We don't have to create everything from scratch when we're using GTK. We can grab the style context from just even a plain vanilla widget and then do things with it. So we're going to add a CSS class to it called view, and that is the CSS class, not to be confused with CSS names, I believe, that is used by a bunch of different GTK widgets, and therefore themes will set various properties for the view class. So for example, anything involving text display, not anything, but many things involving text display in GTK, such as GTK label, GTK entry, GTK text view, I believe, all use the view class. And so to render things like highlighting of text, hint, hint, we will get various colors of the default theme for free. And so that's why we're using that here. Maybe I'll show you if I can remember what happens if you don't do that, okay? We're going to create a new CSS provider, and we're going to bake some CSS into that provider. So here it's &, demo widget, and now where did we set that up? In our init function, we had to do GTK widget set name to be demo widget, and that is what enables us to then go ahead and use that namespace here. You need the # though. With custom widgets, if you're going to do it this way. Okay, we could have put we could have put star there and have it apply to everything, recognizing that's that only this provider will be really applied to this widget, but it's actually a good way to make sure that that you set your name of the widget properly, and down the road, if you want to allow people to be able to create their own custom themes or create their own custom CSS, it's a little bit better to get in the habit of putting the actual name there. Okay. Now we're going to add that provider to the context so that we can then have the CSS fed to the widget, basically. And then on to a completely different topic, we're going to run GTK widget get allocation in order to get the positioning, basically, of the widget, and we pass the address of the allocation struct that we've already initialized at the beginning, or defined rather at the beginning of the function, and that's just going to basically grab the x coordinate, the y coordinate, the width and the height of our widget. Okay. Now all we do is call these two functions, GTK snapshot render background and GTK snapshot render layout, and it takes these parameters here. Note that we're using our allocation.xy width and height, even though it takes a double, and allocation.x is going to be an integer, but C will implicitly convert these integers to doubles, so we don't have to worry about that. The fractions don't matter for this, really. And GTK render layout will then render the text on the screen, and we're just using the x and the y. You don't need the width and the height for rendering the layout because that data is already baked into the layout itself, and we're just putting it right at the top left-hand corner, which is because the allocation.x is the position, the x and the y position in the upper left-hand corner of the widget itself, and so therefore by putting the layout there, we're putting the layout in the upper left-hand corner of the widget. Just make a mental note of that, because we're going to be that's going to be an assumption that we're relying upon, which you probably shouldn't do in production code, but just for this example, it just simplifies the process. Okay, so we've got that. Talked about that. I believe that's everything. I may have missed a couple things, but I'm going to move along. You could always check the code if you'd like to. So make clean make, and if we run the debug test script here, you'll note that the widget is displaying, but we can't do anything with it. Clicking this does nothing. Clicking this does nothing. We can, there we go, resize it. Okay, there's no problem there. You'll note that although we set the border to be red in the CSS that we baked into our C code, it's only appearing on the top and the left. I don't think that that's a bug. I'm pretty sure that that is a function of utilizing the view class. I think that's just how it displays borders when you use that class. If we comment that out and then rebuild and run it again, you'll see that we do now have a border along all the edges. But if we do that, we won't get the benefits of using the view class, which we'll need later on. And so I'm going to go ahead and change that back. Okay. Let me make sure that we're still clean here. We are good. Okay, so let's move on to the next phase. Git checkout part 4_b. Let's do a git diff between this one and part A. So what we're going to do is we are going to add, well, we're going to change a few things here. We're going to add to the object itself. We're going to put the layout there because it simplifies the process later on. You wouldn't always want to do that. It depends on how you're constructing your widget, but because we're just doing a really simple widget here with one Pango layout that does one thing, and we want to keep manipulating it and tapping into it, it just simplifies the process by adding it into the object. And we're also going to cache the positioning of the layout itself by utilizing a GTK rectangle. We're going to have a boolean that tells us whether or not the label is selected, and we're going to have what's called a GTK gesture, which will deal with our mouse clicks, and we'll get into that. We'll get into that soon. We're going to have a render highlights function that will actually render the the highlighting of the text and having it turn on and off, and we'll go through that when we get to it. I'll just skip that for now. We've removed any local variables pertaining to the layout because we've now made it part of the object, and we've added some code here pertaining to the rendering of the highlights again. And now we have a gesture release callback to do with the mouse click. We'll talk about that when I look at the actual code. And we've added, oh yeah, this is in the init function. We initialize certain things there, which we now need to do there because of the way that we can move things around. Okay. I think that we can just take a look at the file. So demo widget.c, and so let's go see where the render highlights is referenced. So what we've basically done is in the snapshot function, we've added a helper function to be run if self arrow label selected is non-zero, true basically in this case. Okay, and here's what it looks like. So we create our context in the same way that we did before. We could have passed that as a parameter to this function and used the same copy of the pointer, but it's so easy just to grab it again, and that gives us one less parameter to have to pass to the helper function. So I just figured we'd put it there. Doesn't really matter. We have a graphene rect t, which is yet another rectangle, and we're going to initialize that on the stack by using this macro here, and we're going to just basically craft it from the GDK rectangle that we have as part of our object and just convert basically that data into this graphene rect t data that we need in the following subroutines. So we're going to save the state of the context. We're going to set the state of the context to be the selected state, and that basically flags the context to be, now when you render stuff, render it in the way in which it would be as if it was selected. So don't draw the background as like a white background now. Draw it as whatever it would be if something's selected in this CSS class or this CSS type. And same with the foreground. And so in order to now pick just a segment of the widget that we're going to draw on, we're going to run GTK snapshot push clip in order to basically grab a certain section to draw on, like I said. And then we're going to run render background only on that section. Basically we run the following parameters on that, but we're using different parameters for x, y, width, and height now. We're only using the rectangles width and height, right, in order to render just a section. And then we're using GTK snapshot render layout, again, just the section of the rectangle, right? And so that's basically what we need to do. And then we're going to pop that snapshot, bring things back to the way they were. We're going to also restore the context, the style context, get things back to the way they were before we started messing with the context to make it into the state selected. Okay, and we are also going to need, let's see, the gesture. Let's see if I can find that. So we set up our gesture in the init function. Self arrow gesture is equal to GTK gesture click new. That actually creates a GTK gesture object and not a GTK gesture click object. So be aware of that. That's why we defined that to be what we did at the beginning, to be a GTK gesture and not a GTK gesture click. Okay, and then we're going to connect that to the released signal because we want people to be able to click and release the mouse button, not just to press the mouse button down to be able to do this action. And we're going to connect it to the gesture released callback, and we're going to pass self to it because that will be able to be converted into a handy dandy self parameter from the user data that we've done before. And then because GTK gestures implement the GTK event controller object, there is no GTK widget add gesture subroutine. There's only a GTK widget add controller. So what we need to do is cast to a GTK event controller our self arrow gesture. Okay, not too complicated once you know what you're doing. All right, and then the released callback from a GTK gesture click follows the following prototype. It takes a GTK gesture click, so a little different, right? So be aware of that. I guess you could probably cut that off and just have it implicitly cast like so, but I like to keep it along with the documentation. This will tell us the number of presses that there have been. A double X and a double Y are the position of the mouse. I believe it's relative to the widget itself. Okay, and then the user data, which we pass self there. So that's how we're going to get our self parameter set up there. And then basically what we're saying is, again, like I said before, we're making the assumption that the layout will be at the top left, okay? And so if X is less than or equal to the width of the rectangle of the layout, that means that we're within the layout. And if it's less than or equal to, if Y rather is less than or equal to the height of the layout, then that means that we're, again, within. It's got to be within that rectangle, and that's how we test for that. And if that is the case, we then run demo widget toggle selection, which is actually a public function that we've made here, which will allow, you'll see why, because we'll then allow our button on the right to be able to use that from outside of this object file / translation unit. And so we want to make that a public function for our purposes. Sometimes you might not need to, but for this purpose we are going to do that. And so what we do is self arrow label selected is equal to the opposite of what it was before. So if self arrow label selected, then we turn it to be false. Otherwise, we make it true. And then we queue a draw, because otherwise it wouldn't know that anything has happened, because all you've done is changed a Boolean. It would have no way of knowing that that is meaningful to the object. And so we queue a draw to tell it, okay, redraw now. And then, as we saw before, if label selected, we render highlights. And so, but this happens in basically the draw function, the snapshot function. So that's why we need to queue a redraw, because that's the only time that it'll ever know to make a difference. Okay. Let's see if there's anything else we need to talk about here. Well, when we set the label, we actually need to do two things now. So we've moved the Pango stuff to here, because it doesn't make sense to have it done in the redraw. That probably should have been done to begin with, but you live and learn. So this is part of the set label function now. We set the text to be of the Pango layout to be self arrow label, which we've already updated here, just like we did before. And then we're going to run Pango layout get size to plug in to these local variables here, integers, label width and label height. But Pango, when they give you sizes back, they multiply by Pango scale, which is 1024, but that's subject to change. You can't assume that that's going to be the number. So don't use magic numbers, use the Pango scale macro and divide. That will give it to you in pixels. So do that for the width and the height. We're baking that into our, or plugging that rather into our GTK rectangle that we're going to use, that we've utilized in other subroutines. And then we queue a draw. Oh, I keep doing that. We queue a draw because, again, it would have no way of knowing that you've changed the rectangle. And then we do a notify by pspec the same way that we did before, so that if the property changes, then things that use properties will know about it. And so, for example, when we use the inspector, we'll be able to change it, and it'll actually dynamically set the label, and it will dynamically redraw and do everything that we needed to do. I think that's everything I wanted to talk about. We got the clicked, we got other stuff. Yeah, I mean, I'm sorry if I've missed a couple of explanations of things, but hopefully that covers most of it. Again, the sources are all available, so you can take a look. Let's run make clean and make, just to make sure that we don't accidentally not recompile something. We want to get a clean compile, okay? So now, if we click this, if we web as, it highlights. If we click it again, it goes away. Now, if we click off, you hear my incessant clicking there, it doesn't work. You have to click within that rectangle. And clicking yo, oh, I guess I guess I did get it to work in this version. I forgot about that. So let's just take a look at the main.c file here. So what we did was we actually connected the signal, the clicked signal really. So we haven't done anything with the signal within the widget yet, but now what we've done is we've added to the main.c file a connection of the button's clicked signal, and we've run swapped. And what that will do is when we run the demo widget toggle selection callback, it will then just automatically utilize demo, basically being the demo widget, as its first parameter as opposed to user data. And because demo widget toggle selection just takes self being the demo widget and no other parameters, the user data will just be silently ignored, which will just call that function when we click the button. And so that's how we got that to work. Yeah, I think that's about it. So now let's go on to the final part, which would be part 4C. And if I make clean here and take a look at, let's run a diff again. We have not made as many changes here, so I think I might just show you the diff here to show you what has changed. Git diff part 4B. So we have changed the signal name from foobar to toggled. So we've created a toggled signal within the demo widget itself, so it's no longer a dummy signal. We have then changed it here as well in the class init function, and now when the toggle selection function is run, we're going to also emit that signal, and so that will allow us to connect it to whatever we'd like to connect it to, but by default we've left it as before no default C handler. And so I'll just show you the main.c file to show you what we did there. And so we've connected the toggled signal of the demo widget to the demo toggled callback function. And now we've got our demo widget says hello happening again. So it's still kind of a dummy function just to test to make sure it's working. But let's just go ahead and take a look at that to make sure. Make clean, make. Let's run debug test.sh again. Okay, we've got everything here. We click here, works. It says demo widget says hello here like we expected. And if we can click the yo as well, every time the toggled signal gets emitted, it's doing that function, that callback function. So either whether we click yo or unclick yo, or if we click on the widget label itself, either way, it doesn't make a difference. It does the same thing. It lights up, it doesn't light up. So let's just take a look at one thing here. I mentioned the view stuff. You'll see what this gives us. So if we comment that out again and then run make, now let's run debug test.sh, you'll see that it works in the sense that the demo widget says hello thing is still happening, and we see some sort of weirdo changes here, but it's not doing what we expect. It's not looking like it's highlighted text, and so that is what using the view class gives us. It gives us all those colors that go along with any widget in the GTK ecosystem that would use the view CSS class. So things like I said before, labels, text editor type stuff, GTK entry, stuff like that. Okay, I think that's quite a bit of ground to cover for one episode. I don't want to overwhelm you guys with anything more. I think we covered a lot of ground today. Thank you so much for watching. Part 5 will hopefully make things a little bit less intense and build up on things a little bit slower. And I know that was a lot of ground that we covered, a lot we went through today. So, but I thank you for watching, of course. I hope that was helpful. If you have any questions, post them in the comments. Don't forget to smash that like button. Don't forget to do whatever you want to do. Subscribe if you want to, or don't. Do what you want to do. But thank you for watching. Good night and good luck.